Hello everyone, my name is Poojitha and today I am going to discuss about the topic called probability distribution function. What do you mean by probability distribution function? It shows that how the probabilities are distributed over the elements. Here it is mathematically represented as fx of x equals to p of x less than or equals to small x. It is also called as cumulative distribution function CDF. In the above equation, capital X represents the random variables and small x is the real number. Here we are going to add all the probabilities until the up to the value of small x. Now let us see an example on capital PDF. In a given experiment, if a random variable x has elements capital X equals to 1, 2, 3, 4, 5 and 6 with the probabilities px of x. Here we are given with capital X values with the probabilities and they are asking us to draw the distribution function of x. As we know the formula of PDF, that is fx of x equals to p of x less than or equals to x. Now we are going to calculate our fx of x1 that equals to p of x less than or equals to x1 that equals to the probability of x1. We are given with 2 by 36. Next, fx of x2 equals to p of x less than or equals to x2, that is px of x1 plus px of x2. Here we are going to calculate both the probabilities, that means x1 and x2. That equals to, we are going to get 10 by 36. Next, fx of x3 that equals to p of x less than or equals to x3. Here we are going to add the three probabilities, that means p of x1 plus p of x2 plus p of x3. We are going to get 2 by 36. Like that, we are calculating up to fx of x6 value. After calculating fx of x values, now we are going to have a table like this with capital X, p of x and fx of x. To draw the function, on the x-axis we are having our capital X value and on the y-axis we are having our fx of x values. By plotting them, we are going to get the graph like this. Now, let us discuss about the relationship to PDF. The PDF is the derivative of the probability distribution function. Here, small PDF represents the probability density function. To get our probability density function, we are going to differentiate our probability distribution function. See here. That means if you know the PDF, fx of x, you can find the small PDF, small fx of x by differentiating it. Here, this shows the relation between them. Now let us discuss about the discrete random variable. A discrete random variable is a variable that takes specific and countable values like 0, 1, 2, 3 and so on. For example, number of heads when tossing 3 coins, number of students present in class. Suppose let us consider tossing 2 coins and here when we take number of heads, they represents getting 0 heads or 1 head or 2 heads, but we don't have the values like 0.5, 0.1, etc. Now what is the distribution function fx of x? The distribution function fx of x is a cumulative sum of all probabilities of x up to a value of small x. Since x is discrete, fx of x takes the form of a staircase. It increases in steps. The height of the each step is equals to the probability of x at that value. As we discussed earlier, it represents same as the capital PDF, but here the x is taken as discrete. Now let us see the mathematical form of the distribution function. If the possible values of x are x1, x2, x3 and so on until xn, the function is written as follows. Fx of x equals to sigma I equals to 1 to n, p of xi into u of x minus xi, where p of xi is the probability that capital X equals to small xi. As we know that here u of x represents the unit step value. Here u of x minus x is the shifted unit step function. What is the unit step function u of x? Here u of x equals to 1 if x greater than or equals to 0 or 0 if x less than 0. It's a function that helps in activating the probability value only if x greater than or equals to xi. Now let us discuss about the continuous random variables. If x is a continuous random variable, the distribution function fx of x is the integration of all continuous probabilities of x up to the value of small x. Definition of distribution function. Let us consider fx of x be a probability function of capital X, a continuous random variable. Then the distribution function of x denoted by fx of x is given as follows. Fx of x equals to integration from minus infinity to x fx of t dt. Here the limits are from minus infinity to x. To get our fx of x, we are going to integrate here the small fx of t value. Now let us discuss about the properties and proofs of capital PDF, that is probability distribution function. First property, here fx of minus infinity equals to 0. That means for negative values, it says that the probability is 0. Proof. The probability is always a non-negative real number. As we discussed, the probability is never gonna be negative value. It is between 0 and 1. An impossible event like x less than or equals to minus infinity has probability 0. Therefore, fx of minus infinity equals to p of x less than or equals to minus infinity that equals to 0. As we discussed, for the negative values, the probability is going to be 0. Next, property number 2. Fx of infinity equals to 1. Here it tells that for positive values, the probability is going to be 1. Explanation and proof. The value fx of infinity represents the probability that the random variable x takes any value less than or equal to infinity. This includes all possible values of x in the sample space. Since the total probability of any random variable across the entire sample space must be 1. As we know, the total probability in the entire space must be equals to 1. It is concluded as follow. Fx of infinity equals to p of x less than or equals to infinity that equals to 1. Here we are going to represent our discrete and continuous distribution functions as follows. Fx of infinity equals to summation x equals to minus infinity to infinity p of x equals to 1. This is for our discrete function, and integral minus infinity to infinity fx of x dx equals to 1. This is for our continuous function. Coming to property 3, it tells that the probability lies between 0 to 1. It is represented as 0 less than or equals to fx of x less than or equals to 1. Here the probability never gonna be exceed below 0 and above 1. It is in between the values of 0 and 1 or equals to 0 or equals to 1. Explanation and proof for that. Since fx of x is a probability value, that is a cumulative total of probabilities up to x, it must lie in the range of probability values, that is 0 to 1. Probability is always between 0 and 1, as we discussed earlier. So the value of the distribution function fx of x can never be negative and it can never exceed 1. Let us move to number 4. Fourth property is, it tells that for x1 less than x2, our fx of x1 less than or equals to fx of x2. Here this x1 less than x2 represents the subset. Explanation and proof for that is, the function fx of x is non-decreasing, meaning it either stays constant or increases. This is because fx of x1 represents the probability that capital X less than or equals to x1, and fx of x2 represents that the probability is x less than or equals to x2. Since x less than x2, the event is this event, x1 event is a subset of x2, so that the probability can't decrease as x increases. Coming to property 5, it says that p of x1 less than capital X less than x2 can be written as fx of x2 minus fx of x1. Let us see the explanation and proof. Suppose we want to find the probability that capital X lies between x1 and x2, inclusive of x2, exclusive of x1. We split this into two disjoint events like capital X1 less than or equals to x1, second x1 less than capital X less than or equals to x2. These two events are mutually exclusive and their union gives the event capital X less than or equals to x2. Here it says that the both events are mutually exclusive. Then it is shown as follows. P of x less than or equals to x2, that equals to P of x less than or equals to x1 plus P of x1 less than capital X less than or equals to x2. By rearranging them, we are going to get our function like this. P of x1 less than x less than or equals to x2 is written as fx of x2 minus fx of x1. In special case, if x2 equals to infinity and x1 equals to 1, x1 equals to x, then it is written as follows. P of x greater than x equals to fx of infinity minus fx of x equals to 1 minus fx of x. Coming to our last property, it says that fx of x plus equals to fx of x. It says that our value is not going to change. That means the probability function is right continuous. And if we approach a point x from right, the value of fx of x is not going to be changed. Means it remains unchanged. Mathematically, it is given as limit epsilon tends to 0 plus fx of x plus epsilon equals to fx of x. Same here, it tells that fx of x value is not going to be changed. These are the properties of the probability distribution function. Thanks to everyone.